Hello and welcome to Longevity Advantage. I'm your host and instructor, Scott Fulton. In this video, we're going to look at our protective biological barriers. It happens to be front of news right now, given where we are in timing with the COVID-19 virus that has everybody's attention. But it actually is an opportunity to step back and understand what are these barriers and why are they so important to our long-term health. So while it may have some immediate relevance for those watching in the current time frame, this will have, I think, long-ranging benefits for you to contribute to your overall health. The first place to start is understanding a different reality perhaps than what we tend to see in the media and hear about, and that's that we really are within a balanced diversity of genetics and symbiotic relationships in constant, complex communication. So what does that mean? Well, what it means is that humans exist within this world of fungi, viruses, and bacteria. We rely on them, they rely on each other, but they don't rely on us. So we need them, but they don't need us. And so when we talk about these complex communications, there's constant communication that goes on between fungi, viruses, and bacteria in ways that we're only beginning to understand, but certainly there's some great science happening in that right now. But if you could imagine within the soil, we now understand that communication can happen across a mile or more between plants. A tree, for example, is able to communicate with all of its seedlings that are growing up in the forest around it. And we understand now that there is a parent-child relationship within the forest. That's relatively new understanding that science has got involved in, but it's changing our views around many things that we previously thought were on the fringe. The result of this, when we think about nature is naturally resilient. And so for humans, our goal is how can we be naturally resilient? So while you see some people that have a Band-Aid approach, really what we want to do is to be inherently or naturally resilient to all of the threats that come at us as part of daily life. So the other thing here to look at is down the bottom right, the bubble size generally correspond to how big is our gene pool when we're talking about it. Within the human body, for example, we're actually probably only about 10% human cells. We're largely made up of bacteria and viruses as well as fungi. Fungi are the hardest to measure in terms of quantity, and while scientists will not necessarily agree on the exact number or distribution, in general, we're talking about trillions. So we're measuring in the trillions of cells and genes within humans, bacteria, and virus and fungi within both in the human and in the environment around us. So massive numbers, massive communication going on around us. So when we talk about barriers, really what we're talking about is an exposure to a dose, and then what's the response to that dose. So in anything, when we take a vitamin, for example, what we're really taking it for is to get some dose response. We want certain milligrams of a vitamin, and how many do we need to get a dose response? So if we look at the extreme example of an astronaut in outer space, you could imagine out there with no atmospheric pressure, temperature of minus 450 degrees, no oxygen, a breach of that suit would cause immediate and catastrophic death. Right? So that's an extreme dose and an extreme response. Thankfully, not many of us have to deal with that on a daily basis. So we look to the hospitals. How do they manage against all of the viruses that they see? So we look at the hospital workers on the left. Typically, they wear a non-woven suit, so that's designed not to allow transfer of anything between either from the outside coming in or the inside going out. Non-permeable gloves, non-permeable eyewear, and then a permeable, typically an N95 respirator. And that's obviously, that has to be permeable for them to be able to breathe. But yet, that really doesn't stop a lot of viruses, because viruses are much smaller than any of the airways and pore spaces within anything that we need to be able to breathe. So a virus is typically going to be maybe 50 to 500 times relative to the opening size. So the opening size is much bigger than the virus. Viruses travel through the air. We're exposed to millions of them every day. Our body is used to it. Obviously, not all viruses are the same, and that's partly what we experience when we see pandemics start to happen. Is it's a different virus, quite different, and our body is perhaps having difficulty processing it. So again, what we want to think about is what's our exposure in terms of what contact frequency. So hospital workers would have high contact frequency. They're under a fair bit of stress, particularly during a pandemic time, working a lot of hours, not getting as much sleep as they need. They're spending more time indoors versus outside. They have emotional stress, and they typically are going to have many of the same underlying diseases that the regular population. So even these folks may have all this PPE on, that doesn't necessarily guarantee them health, and you'll see certainly some health workers will get sick, and unfortunately some will even die as a result of the work that they're trying to do. So that's a bit of an introduction into a dose and a response, and we can look at it perhaps in more practical terms and more physical terms if we imagine the barriers that we build up around us. So we construct these barriers, but as we look to the right, we can see that over time, eventually, an environmental exposure is going to show itself, and it'll start to wear down over time. Now, typically, if we think about this in the context of a human body, and say this beautiful old fort on the left, it's designed for certain pathways for things to come in and out of our body. That's absolutely by design. We need to ingest food, and we want to get certain nutrients into our bloodstream. So that's a way of managing the barriers and external toxins and environmental impacts that will come with that. And so if we look at the door entry here, for example, you notice it's got a couple of different door systems. There's the steel door, which has some open grate system. So they could have that down and allow some air exchange, which is a very normal way. So that you think about the way we would need to breathe, we would want to have the ability for air exchange. And then we may have some secondary methods of managing that exchange as well. So keep that in mind as we go forward. We'll come back to that in a minute. So again, continuing on with dose response, we can think about that in the context of cancer, right? Where with cancer, we know the more exposure we get, so the higher the dose that we get of any particular carcinogen, the more likelihood of contracting cancer. And so here's a simplified example of what's the minimum dose required that caused a cancer. We see as item 2 there. So above that, we can be fairly certain that the likelihood of contracting a cancer is going to go up significantly. That's relatively easy to understand. The much harder part is the lower dose factors, or the lower risk. And that gets into the differences when we see a group of people, or perhaps even in the same family, they've had a similar exposure, but they don't all have the same response. So we can think about what's going on in terms of response, and that starts to get down to their own genetics and their own personal health around how well their body was able to manage the threats or the dose, and that resulted in a different response perhaps than others in the family. We really have 3 biological barriers to focus on, being our eyes, our skin, and our gut. Our eyes are the smallest of the 3 at 0.014 square feet, which is fairly small. But what's unique about our eyes is that they have a wet mucus layer over them at all times, which makes them really attractive to particulate in the air. And so anything in the air that sticks to our skin may not be a big issue for us, but it certainly is a much bigger issue when it gets in our eyes. If you've ever got dust particle in your eye, now that's obviously quite large, but nevertheless, there's still a number of things that are entering into our system that come through our eyes. Next one is our skin, and that's the one that's most obvious to everyone because it's the one in front of us all the time. but it's relatively small at 20 square feet in relation to the big one of all, and that's our gut at 2,700 square feet. So I think that's about 135 times bigger, typically, is what our gut lining is, or a surface area relative to our skin. And the other key difference is our skin is thousands of layers thick and thousands of cells thick. Our gut is only one single cell thick. So that's quite a difference. Large area, very small area that it has, or depth that anything has to penetrate. And that gut lining includes our nose, through our sinuses in our mouth, our throat, right down into our stomach, and all through our intestines and our large intestine and into our rectum. The way I like to think about it is the food and things that we ingest are really heading into a waiting room. And so you're in charge of the waiting room to some degree at least, and you have some control on who you're going to let into the waiting room. But even then, who are you going to let into the inside of your body? So who are you going to let get into your bloodstream? Well, so that's largely dictated by a number of things. For now, let's just think about there's some waiting period of when things get ingested, and what's going to happen with it when it's sitting in that waiting room. Is it going to come into your bloodstream, or are you going to send it away? So I mentioned earlier about hands, and we can look to an operating room as a good example of how do doctors manage this. So what you'll typically see is doctors having their hands up in front of their face, and that's primarily to keep them aware of where their hands are at all times. But it's really that hand-to-face contact that's important. And we want to really work at keeping our hands off of our skin, because once an invader or a virus gets on our skin, it's relatively easy at that point to move into our eye cavities. So as we start to look at the skin, again, another place people tend not to understand very well is we have a microbiome in the skin of our hands. It's a rather complex system because microbiomes are by nature very complex. But we can think about that as a system of bacteria designed to protect us, designed to deal with foreign invaders that come in and either reject them or filter them somehow, will send them away. We may actually find that they're additive, and so we will tend to exchange them as part of boosting our own immune system. And that exists not just on the surface of our skin and down into the pores of our hands. So our microbiome within our hands is really important, and we want to make sure that we treat that with the respect that it deserves, because it's typically our hands that are doing the primary contact with most viruses. And an area where I see tremendous confusion is how to manage isopropyl alcohol, or Purell, which you see in lots of locations, and I see people using it far more than I think they would realize that they need to. So we should think about alcohol for use in perimeters. So when we pass through like that fort, like we pass through the gate, that's a perimeter. When we cross through, we don't want to carry pathogens from the outside into the new space. And when we leave that space that we're in, then we want to make sure that we don't carry that beyond. When we cross through those perimeter lines, those are the places to be using something like alcohol, which is very good for cleaning away a lot of the potential pathogens. The problem is if it gets used too often, it tends to deplete the microbiome that's helpful on our skin, and it actually will crack. And we know of an example of a lab worker who was excessive about using alcohol to clean his skin and contracted HIV, so the AIDS virus, directly through the skin, only through excessive use of alcohol. So it has a place, but generally think about it at perimeters. Otherwise, doctors will recommend soap and water is our best defense for keeping the pathogens off of our skin, and that way, if we can keep it off of our hands, it certainly protects our eyes and every other place in our body as well. So as we think about the barrier again, so I showed you the castle wall in terms of in good shape, and then after a few hundred years of decay, our bodies suffer the same challenge. As we get older, our barriers naturally become weaker. So that's in the long term. But in the short term, our gut lining, that barrier, say that's 2,700 square feet, it actually is highly dynamic and very responsive to relatively low doses of triggers. And so it'll respond in very short order. And in fact, If we think about eating 3 meals a day, it's going to go through at least 3 cycles a day. So here's an example on the left. This is fluorescence microscopy. It was some work done by Drs. Gilday and Bush, affiliated with Biomic Science, on a product that is termed terrahydrate. Don't need to know what that is. All you need to know is that on the left-hand side are epithelial cells. So these are the cells that line our intestines. And in the dark area is the cell, and then the lit up light green area would be the gaps between the cell. So what you see is the cells are all packed in nicely, all in good close contact. So we call those tight junctions because they're in tight clusters together. But then you can see when it gets, on the right hand photo there on the bottom, when it gets exposed to a trigger or some stimulus, what happens is that the cells contract and they lose the adhesion. And once the cells lose the adhesion, this is the barrier between our gut and our bloodstream, which is immediately behind that. And so we know triggers like Roundup, that's why we see Roundup in the news so much, or glyphosate is the active within that. People who have a gluten sensitivity, this is what's happening in their gut lining. Casein associated with dairy, a lot of people get the same trigger, and many medications will also cause that same trigger. So these are unfortunate events that happen without our awareness, and that's really the danger, is we don't see it happening. We only start to realize it's been happening when we get the effects of a chronic disease showing up later, and that could be an autoimmune response as one common example of this. And one of the best ways to treat autoimmune responses is stop allowing the toxins or whatever the trigger is to get into our bloodstream. If we drill down deeper and look at that actual lining of our gut, and this is particularly if you think about our intestines, lined with epithelial cells, again, only one layer thick, one cell thick of cells, so very, very thin, much smaller than a hair, for example, which is several cells thick. In the food that we eat and drink, with it comes the environment that it came from. The environment can include toxins, things like pesticides and gluten. It can include the sugar that was with the food that we ate, the alcohol that was with it, stress and drugs, and it's likely to bring some other environmental aspects with it too, some viruses, fungi and bacteria, and pollutants. And of those, we know the pollutants are bad, but the viruses and bacteria and fungi may or may not be good for us depending on which strain they are. So as those come into our system and they're passing through our epithelial cells or passing over them, if our body sees things like gluten, casein, toxins, any of the stimulants that cause us to respond to them negatively, what's happening is our body's generating zonulin. It's a protein it naturally generates. And when it does that, it opens up the tight junction and allows a free path for those to go straight from our intestines through that one cell gap and into our bloodstream. And then at that point, it's up to our immune system to try to deal with it. So you can imagine the more that gets into our immune system, the more our immune system gets loaded until it gets overloaded. And when this happens for a long period of time, eventually it starts to show up as chronic disease. And at that point, it's really our immune system saying, I'm really overwhelmed for a long period of time. I'm tired and I'm confused. I can't tell the difference between casein, for example, and a cell that's in my joint. I can't tell the difference between a gluten molecule and my thyroid. They look so much alike. I know I have to attack, so I'm going to attack them both. We see a number of these things start to happen, which you could think of as allergic responses, as hives on our skin, for example. But imagine instead of having something that's itchy, this is happening silently in your stomach. So when that's happening, we're getting deleterious immune responses, which in turn causes a lot of oxidative stress, which accelerates aging. It also promotes both acute and chronic disease. So again, the problem is we need to be mindful that if we're not on top of this, it's going to show up much further down the road, and then we've got to find our way back to health. This is much easier to be proactive on it if we can in all areas. So ideally, we want to be on the left side of that screen with a low demand on our immune system. We want our immune system essentially just to be on idle, waiting for the occasional invader to come in and deal with, because that's really what it was designed to do. And that'll keep our system at lower stress, and it'll, oddly enough, keep our bodies at lower stress. So we know now a lot more than we did about the microbiome just 10 years ago. and it really ties closely in with being that first line of defense. It's really responsible for keeping our gut lining healthy, as well as a number of other things. It helps improve our immune function by helping balance the healthy viruses and bacteria versus the invaders. It helps ease digestion. It reduces oxidative stress on our cells. It increases cellular repair rates. Both of those last two help to slow aging, which is good, of course, for most of us, I think. It helps improve bone health by more calcium uptake and naturally helps us migrate to our natural weight. It also improves brain function, both acute function, because of the connection now that we know between our gut and our brain via the vagus nerve, but also it looks like long-term health in terms of things like dementia and Alzheimer's are tied to a healthy microbiome as well. So a great investment both in the near and long term is to pay a little extra attention to helping our microbiome get healthy. So how do we do that? Well, we do that by eating a diverse variety of foods. Want to have that all quality food. When I say variety, I'm not talking about junk food in there. This is a diverse variety of quality foods. Ideally, if you can try some fermented foods, that's one of the best ways to bolster up your natural bacterial balance. They're already resident in your body. You can introduce some more to help them along that way. You want to eat organic whenever possible. The incremental cost of organic is nothing compared to the potential costs of health issues in later life, not to mention the diminished lifestyle that goes along with dealing with disease. We want to work on increasing our NRF2. NRF2 is what's responsible for managing our immune system, and we'll talk about that in another lesson. We also want to look at natural alternatives to pharmaceuticals. Many pharmaceuticals come from natural origins anyway, and if you can do a little bit of research and work with someone on that, you may find some great alternatives that give you an equal or even better benefit than a pharmaceutical. We want to get outside every day for an hour, both to give us several thousand units of vitamin D by being out in the sun, but also we want to do an exchange with the environment outside. That's where the big microbiome is. It's out in the outside world, in the ecology of the environment, and we want to do an exchange with them. We're going to do a microRNA exchange with them. So we're going to actually exchange genetics with the environment, and in turn, we're going to get a huge uptick in overall health. And then finally, we want to look at supplements. Ideally, we get all of the nutrients we need through our food, but often that just isn't possible. So we want to understand where are the gaps. We generally want to do that through getting some blood work done. And then we want to target what are the areas where we know we need some supplementation. Generally now it seems that most of the medical science has turned away from probiotics, primarily because we flood our system with a handful of bacteria. But meanwhile, we upset this balance of 30,000 bacteria that we need to be healthy. We want to move up the stream to prebiotics, or ideally even work on the existing bacteria within our microbiome and just help to bring that up naturally. That's the easiest and best long-term way to do that. So really 3 takeaways I would stress on this one. Viruses, bacteria, and fungi are essential to life. Absolutely essential, absolutely needed. We'll die in a matter of hours without them. The second one there, we want to take good care of our microbiome. That's really a great investment in our long-term health and our best defense against keeping the unwanted invaders at bay and dealing with those very quickly. And the third one there is manage our infectious perimeters. Think about using alcohol, as in isopropyl alcohol, at perimeter crossings. You can have the other kind of alcohol when you get home. So hopefully that was helpful. You've obviously found us on our YouTube page, and that's a great place on our channel here to find some other interviews with doctors, some lessons, coaches, number of different things here, and you're more than welcome to join us at Longevity Advantage on Facebook. We tend to put up a couple of posts a day on any number of topics that people find interesting. So until next time, stay well.